All right, folks, what's up? So we're going to do a million, bazillion, gazillion circle theorem questions. So let's get ready to go. Just going to jump right into it. Late night grind with Uncle Springs. Late night grind. All right, let me just ban this. It have a form one here doing some kind of shipping this primary school students. Let's just get them a little band day. We start off with a band. I mean, we start off good. Nice. So shout out to those of y'all who here again. I had some of you last night here in the late night grind with me. Let's see what's going on TikTok. I think both are working. TikTok is up. This is the circle theorem question we're about to do. Now, circle theorem is a kind of hated topic by many, so I'm not too sure how many people I'll have on the stream here, but I hope that in the future, those of y'all watching in the future, you all know you're here. You're here to lock in and see me do a bunch of these circle theorem questions, right? So you can skip ahead. I'm just doing some housekeeping here. All right, boom, I have this, I have that. Everything looking good, everything sounding good. Hi, sir, I need help. I have test tomorrow. Well, this will definitely help you. You need test tomorrow. Surprise the teacher and mash up the circle terms. What do you think? So we live on TikTok and we are live on YouTube. People are flowing in on the YouTube, man. Big up the YouTube. Let's press like YouTube, people. Let's get that likes up. So we're about to start. Person who's scrolling, I had to try and find where we start. It's now. We're starting now. What I want to start off is create a mind map of all the theorems. So I'm going to try and bring up the terms in my mind, and you can do the same, and I will give them a nickname and like a position in my mind, right? I'll give them a nickname and a position in my mind. I'll just describe what they do, give them a nickname and position in my mind. I'm not giving you the official definition yet. As we do the questions, we'll get a plug in the official definitions, and you'll see me do it over and over there. I get accustomed, right? And the official definitions in the textbook, you could always see them. So in the mind map, you have the first four. The first four popular, and these are all, in my mind, these are all very pointy. The first four pointy popular theorems, right? The first four pointy popular theorems. That's this one. Let's just draw 4 circles. So to be able to like recite all the terms in a row, this is a nice little mind map to help. For those of y'all who locked in tonight, you're in for a treat, right? You should see some good progress in your understanding of circle terms. And you can draw with me to try and help study. This is like a study with me session, right? The piece isn't frenetic. So first four popular theorems, these are like the pointy ones. So we have my guy at the center here. No matter where you put this angle, it's going to be 90 degrees. So this is the semicircle. We have the arrowhead. So this angle at the center is twice the angle at the circumference. We have the bunny ears, what we call the bunny ears. It doesn't matter where you send this arrow, send this angle. Once it's from this chord, it's going to be the same. So this angle is the same. This angle is twice this angle here. And last but not least, in the 4 most popular theorems that you will see is this guy. What is this guy? What do they know about him? Well, so that's 1, 2, 3, and 4. That's the 4 most popular theorems, people. Are they locked in there? So this is 90. In this one, this is double. It's from a common chord. This is also from a common chord. These number 1 and number 2 and 3 are common chords. And this one says that these 2 angles here must add up to 180 degrees. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So what's the nickname we'll use to remember them? So let's give them a nickname to remember each one of them. You kind of heard me use some of the nicknames already. This one is the semicircle. So you'll hear the students using this as well. And now you know what they're talking about. Angles in a semicircle is 90 degrees. No, there's a neater way to say it to collect the marks. We're not doing that yet. We're just trying to store it and understand it. This is the arrowhead theorem. Now, it doesn't always look like an arrowhead. It can hide and look like this. But we learn it like the arrowhead, right? It can hide and look like this. And what it says is the angle at the center is always twice the angle at the circumference. So if this is 100, this must be 50. Useful, right? Useful. This one is the bunny ears. Bunny ears. We kind of update this in 2026, my class. So this is what I used to call it back in 2018. This become very popular now. A lot of people are here saying bunny ears, and this is something I started in 2018 on the channel. I used to call it bunny ears back in school. Now this one is the updated name is Batman. This is the Batman term, right? It was 2 pointy ears, right? So you may see me see bunny ears or Batman. And this one is the cyclic quad. Cyclic quadrilateral. A quadrilateral is a four-sided figure, in case you don't know. Quadrilateral. Quadrilateral. Too much L's in this thing here, boy. Quadrilateral. So this like cyclic quadrilateral. It says the opposite angles at 180. And the Batman theorem says that if this angle is like 30, this angle here must be 30 as well. It must be the same. So everybody understand the first four terms as the most popular terms. Everybody locked? If you're locked in, type locked in. Locked in the chat. So the first four terms there, those of you all watching in the future, 1, 2, 3, 4. So we kind of learn them like that. We map it up like that. Then we have basically a useless a useless term. One that doesn't really show up at all. The forever alone term. And then we have two tangent theorems. Wait, before we do that, we have the obvious theorem. Obvious theorem. Then we have two tangent theorems. And then the GOAT of all theorems, the big boy theorem. So the first four most popular, that's our mind map. We all understand what we're doing, right? We're kind of creating a way to remember this. If you're studying it, it's a study session. So we have our first four most popular theorems. We have the forever alone. We have two tangent theorems that are locked in there. We have an obvious theorem. So first four most popular, this is the forever alone theorem. You never saw this theorem in any circle theorems question ever. Let me draw it for you, and I want you to see. Go and see if you ever find this theorem anyway. So if this theorem says that if you run a line, if you run a chord is any line drawn from one end of the circumference to the next end of the circumference in a circle. The largest chord is the diameter. So if you run a chord and you bisect it, you perpendicularly bisect it. You know, to bisect a line, you split it in two and you run a 90 degrees. That line is going to cut through the center. That's what that term is basically saying. Have you ever seen that in any CXC question? This term more deals with measurement of the lines. It's like it splits the line into two equal places. So usually circle theorem question deals with angles. So this is why you would probably never really see this in any paper. So that's the forever alone term. The radius is the perpendicular bisector to a given chord. And this theorem is very useful. The next one I'm about to show you is the obvious theorem, and it shows up extremely. It will give these terms a run for their money. It just show up. It's almost like it shouldn't be a term. It should just be a thing. Like it should just be a thing. What is this term about? If you have a circle and you make two radius, what am I doing them with? Red, and you make two radius. Where's the red? Any two radius anyway, you do, and you connect that along the 2 points to make a complete triangle. Guess what type of triangle you just made there? That's what this term is about. It's obvious. This is a radius, this is a radius, they're equal. You just made an isosceles triangle. Two radii equal an isosceles triangle. And what are the two? These are the two tangent theorems. So these two here, 7 and 8, are the tangent, and this is the GOAT. The greatest of all theorems, the bad boy, final boss. It's not the greatest of all, actually. It's just the final boss theorem. The greatest theorems are 1, 2, and 3, and 4. These are the most popular. These are where you're going to get most of your marks from, and including the obvious. So the tangent theorems, there are there are actually 3, because the final boss is kind of like a tangent theorem as well. So it's kind of like these 3, but the last one is that. The tangent theorems, What are they about? So we're going to have to draw tangents for these terms. The 7 and 9, I could just go ahead and draw the tangent one time. What's a tangent? What is a tangent? A tangent is a line drawn outside of a circle that touches the circumference of the circle once and can only touch it once. It's a friend zone line. It doesn't intersect the circle. It's outside. You can touch the circle once. Does not go in the circle. You all understand? That's a tangent. Now, the term number 7 says that if you draw from the center of the circle to the tangent, to the point of the tangency, that is always going to be 90 degrees. That is also going to be a radius, and it's going to be the normal to the tangent. Normal in maths and physics just means meets at 90 degrees. That's what normal means. A normal force is a force that hits something at 90 degrees. If I hit you a normal slap, I mean the slap come at 90 degrees. You get a normal slap. Understand? If I approach my friend normally, I approach them at a 90-degree angle. So normal means 90 degrees. So the tangent and the normal meet at 90 degrees, and this normal is a radius. So that's what that tangent is, that theorem is all about. This theorem is the only theorem, number 8, that deals with a point outside the line. A point outside the line like this. And what it's saying in, let me just draw these lines in red to match my color scheme here. Since somebody's spazzing out over, I'm messing up my color scheme. Yeah, so a point outside a circle, if I try to connect this to the circle, not like this, with a tangent, so that I create a tangent from a point outside the circle, I do on the next tangent on the next side. These two lines here to the point of tangency will be equal. So from a point P to, I'm not going to use letters yet. I just showing you the basics right now, right? So what this also does is create an equilateral triangle. That's the most useful idea with that. Now, this is very rare. It comes like once every 10 years. But when it comes, it's very obvious. It's a point outside the circle. It's the only tangent that delimits a whole point outside of the circle like that, right? Now, these could have points outside the circle, but not forming two lines coming like this. So let's just take a recap for those of you all who just joined. What we are doing is creating a mind map. We are creating a mind map to just memorize all of the terms in a nice, neat way. Mind map. The first 4 popular terms, the semicircle, angles in a semicircle, 90 degrees. Now, I'm not giving you the full definition yet. We'll do it as we do in the questions. The arrowhead. Arrowhead means this part of the arrowhead is twice this. So angle at the center is twice the size as the angle at the circumference. Reminder, it doesn't always come as an arrowhead. It could come hidden like this or like this, where this is still twice that angle there. The bunny ears, new name for 26, the Batman theorem. The cyclic quadrilateral. In the Batman theorem, these two angles are equal. In the cyclic quadrilateral, we have these opposite angles are supplementary, meaning add up to 180 degrees. Your forever alone term that doesn't get used for nothing. That's the chord, perpendicular bisector for the chord will pass through the center of the circle, form the radius. The obvious theorem, 2 radius, and if you connect it to make a triangle, that's a nice isosceles triangle because it's 2 radius, 2 radii, I should say. The tangential terms are the last 3. Everybody understanding? All you see any terms, you know, probably never got it explained like this before, but I hope that this has been very useful to you. The tangential theorems, so it deals with a normal and a tangent, this first one. And it says that the tangent meets the circle. At the point of tangency to the center is the normal to the circle, and it's also the radius, coincidentally. A point outside of the circle, if you draw 2 lines so that it makes 2 tangents to the circle, this is equal. These lines are equal in length. And the final boss says that if a tangent meets a circle, and I draw not a radius this time, not a radius, people just mix it up, not a radius. I draw a chord. A chord is just any line from one end to the next end of this circle. This angle that you create between the chord and the tangent gets to be equal to the angle in the alternate segment or the opposite segment. Wherever I draw this triangle, it doesn't, because that's the Batman, right? That the bunny is. It doesn't matter where I draw that triangle. This angle is now equal to that angle. All right. You all want to do a quick quiz on this before we jump into the questions? A quick quiz. I'll just draw some random circles and you all have to guess the theorem. You could use the nicknames to guess it. Let me do that survey on YouTube. YouTube, well, you want to do the quick quiz or you want to jump into the questions? Quick quiz? Yeah, let's do the quick quiz, right? So I'll just be drawing random things and you all need to shout out the theorem and get the value of the missing angle. It's very simple, right? So I need to get this a little bigger. So if I have a circle, I need some good circles, boy. Let me just get some circles drawn first. This thing taking very long to change my circles into circles. Or I just prepping up my circles for the quick quiz here. That is not a circle, that is an alu pie. We had to take down the video. I didn't want to expose some of the names of those students. All I can tell you is those classes be real entertaining classes. If you know, you know. All right, so I have like 9 here. Let's draw a few more. We're going to do a quick quiz. All I'm going to do is draw one thing and set up on a circle and create a missing angle. And you all will need to guess what the missing angle is. Are you ready? Connect my circle. Come on, man. The people waiting on you. Nice. There you go. Hey, real circle draw there, boy. So on your marks, get set, go. Find the value of x if this is 140 degrees. What theorem and what is the value of x? Yes, that is the cyclic quadrilateral theorem, and x is going to be 40. So x is 40. And this is your cyclic quad. All you understand the name of the game now? Call your friends. Get them ready to play. So, find the value of x. Find the value of x. What theorem and what is the value of x? All right, so I've seen people saying x is 23. And what is the theorem? X is 23. And this is the arrowhead theorem. Angles at the center is twice the angles at the circumference. Good, 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 good. Find the value of x here. What theorem? Find the value of x. So a couple of people fall from a dastardly trick. A couple of people saying that this is the Batman theorem. Is this the Batman theorem? Dun, 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 dun. If it was the Batman theorem, this would have gone up here. But the Batman theorem, both of the subtended lines from the chord need to meet at the circumference. This is a bootleg Batman theorem. This is once again the arrowhead theorem, people. This is the angle at the center is twice the angles at the circumference. See how sneaky it could come? And I'm not giving you all the full question yet. I'm just giving you all a one angle find out. One angle, one hit. We good? Are we cooking? Find the value of x. Find the value of x. What is x? What is the term? What is x? What is the term? So this is the term to do with the point outside the circle, yes. So this is the term to do with point outside circle. And it creates two tangents that are equal. So they are isosceles. Yes. So it's anytime you have this is a popular calculation. Mini segue. Mini side quest, everybody. This is a calculation you're going to do with circle terms regularly. If you have an isosceles triangle and they give you this angle, let's say they give you this angle is 30 degrees. How do you find out the base angles? Let's say the base angle is called y. Well, y is going to be 180 minus the 30 degrees. This 30 degrees here, you need to subtract it from all the angles in a triangle. So 180 minus the 30 degrees, and that will mean you'll get the value of these two angles. So divided by 2 in the end. Divided by 2. So 180 minus 30 is 150 divided by 2 is, in this case, what is it going to be? 75. Cooking. This is a very popular calculation. Popular calculation in circle terms. Back away from the side quest here. So if we do that calculation here, x is going to be 180 minus the 74 divided by 2, which is how much? 180 minus 74 is 106 divided by 2 is 53. So x is 53. So this is the point outside the circle creating two tangents. We getting there? Are we getting there, ladies and gents? Find the values of x. What theorem? Find the value of x. I see some people say semicircle. And if you're thinking Batman, it's not Batman, it's not semicircle. What is this? Anytime you see 4 points hit, bang, 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 bang. Cyclic quad. Cyclic quad. So this is the cyclic quad term. Cyclic quad. So what is x? Therefore, x is 180 minus 65, which is 115. Cyclic quads, opposite angles in a cyclic quadrilateral add up to 180 degrees. The short word for that is so this is side quest 1. Side quest 2. Side quest 2. You should know that the word supplementary means what? What does supplementary mean? Adds up to 180 degrees. Adds up to 180 degrees. So the opposite angles in a cyclic quadrilateral add up to 180 degrees. Great. Let's keep moving. Find the value of x. What term? Find the value of x. What term is this? Find the value of x. So this is the semicircle term you're going to use to help you find the value of x. Angles in a semicircle, 90. So x is not 90. X is, if this is 90, these two must add up to 90 as well, complementary. Or all the angles in a triangle add up to 180, minus the 90 minus the 30, and you'll get what x is. So x is equal to 180 minus the 90 plus the 30, which is 60 degrees. 60 degrees. Cooking. Everybody catch those first three? You feeling like you're ready for a full past paper question now? Let's go again. One second. Find the value of x, then find the value of y. Find the value of x, then find the value of y. So we are seeing the arrowhead theorem, but we can't use that immediately because we don't know x or y. The arrowhead means that if whatever this is, this needs to be half of that. So if I have this as 48, well, I seen you all seeing it as 45, so fine. Let's say this is 45. If this is 45, it means this is also 45. That's a theorem. That's the obvious theorem. That's the theorem with the radius. These two radius make it an isosceles triangle. So if this is 45, this is 45, 45 and 45 make 90 minus, you get your 90 there. So x is equal to 180 minus 45 and 45. The angles in a triangle. I'll show you how to write this up just now as we do in the past papers. And if this is 90, what is y? Y has to be half the size. Y is 45. Are we cooking, class? I've seen people starting to get it out real fast on YouTube. Yeah, now watching my TikTok people. TikTok people, are they happy? We have 53 people on the TikTok sweat too. So bless up to the TikTok area. So they can press follow. Help out our brethren. Let's do another one. Find the value of x, then find the value of y. Hold on, I need to tell you something first. I want to do one thing first, people, but I don't want it to be obvious. I only wanted to make the question simple, but I had to make this one a little complicated. Find the value of x, then find the value of y. Some of you all have it already. Find the value of x, then find the value of y. X, then y. Now stop and think. There was a reason I had to do what I had to do there. Stop and think. Maybe you had a thought and you need to unthink that thought. What is x? What is y? Now, one of the things that kill people who start to get good in circle theorems is assumptions. You could only go based off of theorems or facts. So anybody who assumed that this is 90 degrees, that's wrong. That's not a semicircle. I draw the center point over here. It missed. So you can't assume that this is 90. This is not 90. So try again. Try again one time. Try again one time. If you was assuming the semicircle, try again. So therefore, what we need to use first, it's actually 100. Very good, Tanisha. We need to use the cyclic quad. Use the cyclic quadrilateral first. And this turns out to be 100. Therefore, x is 48. 48 and 32 would make back the 180. Not 58, 48. X is 48. Why? Because this is not 90, it's 100. 100 plus 32 plus 48 will make the 180. So you use the cyclic quad first. Side quest. You have seen it happen a few times now. Side quest 3. It is extremely popular. To know that all the angles in a triangle add up to 180 degrees. Extremely popular. That's going to happen. You're going to have a triangle there, right? So after you found that this is 100 and this is 32, we know that x is 48 because 132 from 180 is 48. And then if x is 48, guess who gets to be 48 as well? And why does it get to be 48? That's the final boss theorem. Angle between a chord and a tangent is equal to the angle in the triangle in the alternate segment. So y and x are actually equal to each other. AST, alternate segment theorem. Good, 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 good. I think we're cooking. Everybody's starting to see. You're starting to see a way. I'm going to tell you all a secret afterwards. Secret side quest. Secret side quest. It's coming just now. I'll tell you all the secret just now. Just now. Which theorem am I testing you on now? Right. Find the value of x. Yes, sir. So this is a clear case of Batman theorem. Clear case of the Batman theorem here. Common chord. The official thing is angles from a common chord in the same segment. Angles subtended, you want to use that word. Subtended means you draw straight lines from the end. Angles subtended from a common chord in the same segment are equal. So x is equal to 50 degrees. All right, so we did 9 quick sketches here to try and get some terms out of the way just to get like some basic understanding of it. So side quest 4. Side quest 4 is a secret that I've been saying over and over. This is the topic that requires the most practice. It's very deceptive. When the teacher do it on the board, all of a sudden, hands looking like he leg. When the teacher do it on the board, all of a sudden you feel like, yes, I understand this. This makes perfect sense. And you sit down there thinking, I am a genius. I could understand this in maths. But then when it's time to do it for yourself, pressure. So you need to practice this a lot, which is why you are here. So welcome to the past paper, January 2010. Let's go. We need to get GFH. I'm writing the ones we need to get here. Just now I need to refresh this. So we need to get GFH, GDE, and DEF. GFH, GDE, and DEF. Let's go. Now, you will get to see how I use the reasoning. So I'm seeing some answers popping in the chat already. Malik is killing it, as usual. Angles are the circumference. What are you thinking, TikTok? TikTok, I hear you. Are you seeing your terms popping in? I'm going to just load it over on my board so I could write a little more. So we need to get GFH, GDE, and DEF. In case you're not seeing the angles, let me just write them in for you. And I can see them, man. You can see that that is 88, right? That is 88, and that is 126. So GFH, GDE, and DEF. So this one, they decided to combine 2 circles together. What is GFH? So firstly, you need to be able to find GFH. GFH is here. We clearly see now arrowhead theorem. Now, let's see how we would state this. So we cannot GFH. So here, take note of this, everybody. Start writing with me. So when I'm using the term, I use the letters to help me. So that's a secret that you can apply. Hidden secret of the trade. So angle GCE is equal to 88 degrees. Angle GFH is subtended from the chord GH, which is common to GCE. So angles from a common chord at the center is twice the angle at the circumference. Therefore, which one? GC, which is common to GCE. Since C is the center, GFE is equal to half GCE. So this is the best way that you can use circle theorems. Apply the theorem with the letters in the questions. So to just state the theorem dry, state the theorem with the letters. So the theorem itself says that the angle from a common chord to the center of the circle is twice the angle from the same chord to the circumference of the circle. Or we want to knot it into the question. Everybody understand what I'm doing? So you have your theorem, you have your rational, like almost like a formula coming down here. Then you state half of 88 and you get your 44. So spotting the theorem and getting it out is one thing. This is where some students struggle to put it into words. So practice that. It requires the most practice. What's the next one they want? GDE. GDE. So how are we going to figure this one out, class? The last angle was DEF. What do I wanted? GFH? GFH? Sorry, GFH. Do I have GFE written there? It's GFH you want, right? GFH. My bad. But it's the same thing. GFH is half of GCE. So the next one is GDE. That's definitely a cyclic quad. Do you see the cyclic quad? It sometimes hides. Side quest. What side quest you on? Side quest 5. Side quest 5 earlier. What do you think I'm going to tell you in this side quest? This side quest 5 is the only instruction I have for you when it comes to going in the exam. You enter the exam room. The first thing you look at when you are asked to open your paper is what? Turn to question 9, where's the circle terms are? And you are looking for, look for the cyclic quad and other terms, but especially the cyclic quadrilateral. The reason I give this is because every time I'm doing the solutions online right after the exam, you could go and watch. You can go and watch in the lives, right? As I'm doing the solutions in the past few years online, people are always bawling about it. Oh, I didn't see that term. Oh, I didn't see that term. So I want you, the first thing to do is turn to question 9 and look for your terms, especially this fella here. I'm sure some of you all didn't even see him just now. Ready? So if I would do this like opposite angles, and I'll state my opposite angles that I'm looking at. EHG, comma, EDG in a cyclic quadrilateral are what? What's the fancy word? Are supplementary. That was one of our side quests, right? Supplementary. Supplementary. Mentary. So therefore, EHG DG, that's what we want. What we want? GDE, same thing. GDE is equal, they wanted like GDE, is the same angle though. GDE is equal to 180 minus EHG. You all understand? 180 minus 126, and everybody was saying what that was already. That is going to be, no, not everybody, yes, everybody was saying it early up, 54 degrees. Cooking. Last man, DEF. Where's DEF? DEF. Yes, DEF. How we getting that? Did they give us anything about this? Did they state any? C is the center smaller, GH and DEF is a triangle. Angle GHE is 126, not drawn to scale, shows two circles, smaller circle. GH is a common chord. It's a common chord. So if it's a common chord, it's similar triangles. So if it's similar triangles, what that mean? This means this is parallel to this. So have quite a few ways we can figure out what that is. You can either use that this is an isosceles triangle now, or you could use co-interior angles, or you can use all the angles in a quadrilateral. You could use real plenty things. Nothing here is a tangent to nothing. I've seen some people talking about tangents. Seen some people mentioning tangents. This is an isosceles triangle. This is equal to this. There's no tangent here. Tangent will touch the circle and only touch the circle once. So a tangent to this will look like this, and a tangent to this is like maybe this here. This may have been a tangent. But there's no tangent rule here. It's isoscelesing. It's isoscelesing, which is not a word. I wonder why they shade this sector. What I have to do with anything? Using pi calculate. No, we're not doing that part. We're not doing that part. They want you to do. So in this, they actually use the This is for trigonometry. They actually use the bearings part here. All right, so we'll run with the 54. Cooking. And you could use any one of the reasons. Co-interior angles are supplementary. So if you have two parallel lines, a quick side quest, we're going to jump into the next question just now. Quick side quest. Sometimes this shows up in this type of questions. If you have two parallel lines, you create two situations. This is called complementary. You all could look up anything that I have on bearings. This is called not complementary. Corresponding. This is called co-interior. This is called alternate. And this is called co-exterior. Now the corresponding angles are equal. Vertically opposite angles are equal. Alternate angles are equal. So for example, if this was 80 degrees, this is 80 degrees. This is 80 degrees. This is 80 degrees. This is corresponding with this. It's alternate with this. And it's vertically opposite to that. It's co-interior with this angle here. So this will have to be 100. So co-interior angles are supplementary, add up to 180 degrees. So that's our next side quest. I think that was side quest 6. Keep it pumping. We have to go on to the next one. We want to do a good few. So what you do, the first thing you do is watch here and see if there's any new friends, any new things. PQ is tangential. So you'll just write tangent here. So I already thinking one of the tangent theorems. To the circle PTRS, so that RPQ is 46. RPQ is 46, that was given. RQP is 32, also given. This didn't do the double tangent thing here, so I'll throw away that term from my mind. calculate given a reason for each step, PTR, TPR, TSR. Everybody take a look. Somebody said they've seen the cyclic quad already. Lock in, everybody, lock in. I didn't write out the full definition for the last one just now. I kind of talk it, but I didn't write it out. I'll write out some more here. Let me just keep going forward. PTR, PTR, PTR. Yes, sir. Anytime you're struggling to figure out something, always remember the final boss. Who's the final boss? Alternate segment theorem. Now, anytime you see tangent, you immediately think the last three terms are 7, 8, 9. That was the theorem that like this. Then you have the theorem where it like this, 90 degrees, and then the alternate segment theorem. Those are those theorems, the alternate segment theorem. The alternate segment theorem says that if you have a tangent and a chord is equal to the angle in the triangle in the opposite, in the alternate segment. So here's how you write this. Here's how you write this. PTR is 46 because of the dreaded alternate segment. Victor, you're killing it. So this is 46. By the way, when you get an angle, write it in, right? So here's how I'd write this. Let me see if I can get some space. The angle, in brackets, I'm looking at the angle RPQ. The angle RPQ between between the tangent, what's the tangent here? The tangent PQ and the chord, what's the chord that I'm looking at? PR is equal to the angle in the alternate segment I would actually put the angle here. The angle in the alternate set, the angle PTR, which is what I want, right? PTR. In the alternate segment subtended from the chord PR. That's overkill, but we killing them hard. So this is PTR is equal to RPQ is equal to 46 degrees. Reason. But you see how I find a way to tie in the angles that I'm talking about with the theorem? So that's the super move there. That's the I want to be on the merit list and not lose a single mark. TPR, and many of the students on the student always hit the merit list. TPR. Okay, what you all got for TPR? Are we seeing a triangle somewhere? The first thing you always look at is for these triangles. We must spot some triangles somewhere. I'm seeing this big triangle. And I know this angle, I know this angle. I just need to know this one. Angles in a triangle add up here. You have to write a TPR. So angles in a triangle, that's triangle PTQ, add up to 180 degrees. Therefore, I can get angle TPR. TPR must be equal, when you're talking about the angle, it's customary to put a little hat on the middle term, right? TPR is equal to 180 degrees minus the sum of all these other fellas here. 46, that was 46. And about 32. How much is all of that? What is TPR, people? That's not I seen like it. I seen like it has somebody in here need a block. What going on with you, boy? Everything all right by Queen fam, boy? Take a little time out and think about what you're writing. Any people them chat now, man. Everything all right? Queen, you're good? All right, so yeah, we got 56. 56 degrees. Yeah, 56 degrees. TPR, that was TPR. So what was that? TPR is 56 degrees now. What else? TSR. TSR. Who we seeing? Now, TSR could mess up real students. TSR, because you're so busy locked into this view, you're not seeing it. But if you did the quest that I told you, that is an important quest, and you went and you look in the start of the paper for your cyclic quadrilateral, you would have seen and you'd have made note. Yes? So opposite angles and the opposite angles that I'm looking at here are TPR and TSR in a in the cyclic quadrilateral it's PTRS are supplementary. Therefore, TSR is equal to 180 minus 56 is 124. Rate out of 10, how much y'all understanding these circle theorems, ladies and gents? Now, for the sake of speed, I wouldn't be going through the full explanation, the full answers for the next set. I will say it, but I wouldn't write it for the sake of speed, so we can get more done, right? But I hope everybody understanding what we need to do. So we need to get OGF and DEF. OGF and DEF. These are past paper questions. OGF, I think this needs to be slightly bigger. OGF and DEF. Let's go. OGF and DEF. OGF, DEF. Obvious theorem, right? You found OGF yet? OGF is our obvious theorem. It will help if I do this all of a sudden. You see what I'm looking for. OGF. That angle. But that's an isosceles triangle. So you'd say OG is equal to OF. OG is equal to OF is equal to a radius. The one DEF next, right? DEF. Therefore, angle OGF is equal to 180 minus 118 divided by 2, which is 31. 31, 31, 62, 2, 7, T, 80, 180, yes, so 31 degrees. Class, are we cooking? Angles in a triangle add up to 180. You need to see that as well. So, what's the next one? DEF now. DEF. DEF. I'm seeing something for DEF, but you have to be careful. So the 90 don't add up there. Can we use alternate segment theorem? No, there's no alternate segment theorem here. There's no alternate segment theorem. If this is 65, then I need something here to be 65, like this or this. They didn't lock these two together, so that's not I can't use alternate segment theorem there. Angle between a line and a chord, a tangent and a chord is equal to the angle in the triangle, not in the quadrilateral. So what do we use to get the EF? Now, one of the things that you do is kind of see what you want and then see if there's anything you're making a mad scramble like you're reaching for a life jacket. What can I use with this? I'm seeing the cyclic quadrilateral opposite to this is this. Do I know this? That's my next question. Do I know what this is? Can I figure out what that is? That's my next question. I don't know what it is. Can I figure out what it is? I'm just missing this piece. I actually just figured out that this piece is 31. Now, can I figure out this piece then? Well, yes, because this is 90. How I know this is 90? That's a radius and a tangent. Class, you see the way forward here? Are we seeing the light? So therefore, this has to be 25 degrees. You have to state all the terms. So the angle between a radius and a tangent the angle between radius OG and tangent SH or SGH is 90 degrees. Therefore, this angle, and I would have labeled it, or I can say DGO is equal to 90 minus 65 is 25. And then 25 and 31, it makes how much? 25 and 31 makes 56. So if that is 56, yeah, you want to state all the terms that you use to get to your answer. If that is 56, what is the size of the angle over there? Opposite angles in a cyclic quadrilateral are supplementary. So therefore, DEF, which is what I want, is equal to 180 minus the 56, which is 124 degrees. So let's quickly talk through everything again, because I feel like I lost a couple of people here. Seeing like, why my eraser? Why? Wow, my computer freezing up, but I didn't want to show my eraser and thing. Well, we just scroll back down to that one. Which one it is? This? OG, yeah. So what we did, everybody lock in, is we got this radius, that's a radius. So therefore, it's an isosceles triangle. Since it's an isosceles triangle, the base angles in an isosceles triangle are equal. You have to state that. You get your 31, you get your 31 here, and all of these now add up to 180. You subtract this from 180, divide by 2. We wanted to find this angle next, DEF. Now, I deduced that there's a kite here, a cyclic quadrilateral. So I want this, something looking like a kite. I want this angle here. If I can figure out this angle, I can figure out that angle. But I'm missing this piece. Now, this piece is also missing from this 90 degrees. Because this is OG. OG is a radius, and this is a tangent. So this is 90 degrees. And that's how I was able to figure out that this is 25 degrees. 25 and 31 is 56. So I got this whole angle now. Opposite side, 124. It needs to add up to 180. So 124 degrees. Next question. Now you need to put the reasoning for all of that. XYZ. So we're trying to get XYZ, YXZ, and OXZ. Once the XZs you're trying to get here, boy. What? This is confusing. All these letters. Don't use these letters in the exams. XZ, them XYZ and things just looking. People with mild case of dyslexia and thing will real struggle with this, boy. We're trying to get these angles. Now there's some new information given here. They told us that it was a tangent. That's it. Tangent O is the center. So anytime I hear something is the center, I put the center point if they don't have it. And this is 23. XYZ, let's go. Come up with it. I'm just giving you a little time, especially those watching in the future, to catch it. XYZ. So XYZ, oh yeah, we have a clear case of the cyclic quads. Cyclic quads here again, right? So 180 minus 64. Yeah, 116. Cyclic quads again. Cooking, chat. Chat, well done. YXZ. That's not, I need to fix this thing before TikTok kicked me out here. TikTok, you need to stop bringing this. They disconnect my TikTok, boy. Well, TikTok people just had to come across here. TikTok Arians, we just had to come across. What do you want? XYZ? YXZ. YXZ. So there was this little piece of angle here, boy. How we figuring out? AST. So isn't W and O, W and O? Oh, I don't know what you're talking about. So this one is alternate segment theorem, AST. So if this is 23, this also has to be 23. Everybody was able to see that? Angle between a tangent and a chord is equal to the angle in the triangle in the alternate segment. So the angle subtended from Y and Z in the alternate segment is also 23. OXZ now. OXZ. OXZ. OXZ is simple. This question was very distracting. It could lead you down one star wrong roads. Another day at 3 classes in a row. OXZ. Very distracting. Well, the thing is, if this is 64, we know that this is 128. I know a lot of y'all were looking around here to see if you could figure out OXZ and this and that. Now, that's distracting you. Because remember, this is an isosceles triangle, 2 radius. All of a sudden, you're seeing it now again, right? Seeing it now? So you use the arrowheads, the angle at the center from the common chord XZ is twice the angle at the circumference, W. So if this is 64, this is 128. And if this is 128, 180 minus 128 is how much? 2, 5, 52. So it means these two angles here must add up to 52. Now remember, I told you all this is a popular calculation where you do 180 minus 128 and divide by 2 one time to figure it out. And you get 26. So this was on a difficulty. This one was pretty tough. You'd be surprised. Just look back the same question of June 2011 and come back and do it for yourself. You might be surprised. You forget. You figure it out too. Do they use trapeziums? No, not really. It could be a trapezium, but you're only using the theorems. There's no trapezium theorem per se. You should know that all the angles in a quadrilateral add up to 360. That could come in useful. So let's keep going. New question. Feel like I do this one a million times in my life. O-U-Z, UZ, U-V-Y, U-V. So U-V-Y and U-W-O. This is not this man thing. No, it's O-W-O. Let's go. Is there any new information? No new information. So see if y'all can figure out this. Little head start again. Thirty-five. Did I mute myself? When I mute myself? I good now, right? So yeah, this is 35. So let me just say back all of that thing that I just say back there. I was saying that all of these fellas here had to be the same thing. All of them are radius. So all of these are equal. And anytime you set up something like this, in case you're wondering, if I make a setup like this, 2 lines straight like this, and I say that this is 45 and these lines are straight, this had to be 45 too, you know. No if, but, or maybe, you know. Here's why. Here's why. If this is 45, then what do you think this will be? Now 135, because this is angle on a straight line. But this is also on a straight line too. So now this will have to add. This will have to add back up and make 45. And then this is on a straight line too. So this is 135. So if you're ever wondering about that, yes, it's true. Like if I do something like this and I say that this is 30 degrees, this is also 30 degrees. And this will be 150. And this will also be 150. You call it vertically opposite angles. And so if this is 70, here is 70. This is 70, 70. And then this will have to be 110. And then this will also be 110. But if this is 110, you do the isosceles thing, you subtract from 180 divided by 2, you'll get a 35 and a 35. So UV, Y, UV, where's V? VY, this angle over here now. What are you going to be? Well, we know that this has to be a 90. We know that this will also be 35. So what do you think you're going to be? You see the big triangle here? That will be. Oh, some of you all got the 35 by saying 70. Half of that is 35. So this is 35. That's a lot of terms will get you to the same part in the river here. So this is going to be 55, right? To the same C. 55 and 35 is 90. This is 90. So we have 55 and UWO. UWO. Well, we have all the angles in that triangle, you know, so we good to go with you, you know. The first thing I do is the first thing, guys, you don't have much more time again. We only have like 2 questions again, right? I reach my limit and I could go whole night, but I have other obligations. And my wife watching me by the door days. So this is 70, this is 90. So I could just finish up this triangle real fast and get the 20 degrees. Or I could use the 90 and 35 and 35 if I'm feeling extra to get that triangle. We cooking? Let's do 2 more real fast. Let's race through 2 more. I'm not doing the congruent and all of that. We just focusing on the rules. This is a weird looking one that came in January 2013. MRQ. We'll come back again and I feel we'll come back again and grind some more. This is going to be a part 1. PMR. You already remind me what year we reach. PMN. And don't let it be that I doing more than you, eh? MRQ. This season, this exam season, never let it be that it could be said that Kerwin Spring are doing more than you and you had to write the exam. MRQ. MRQ. 3 marks, ladies and gents, because this is the center. So those who love the first theorem, you know it's your time to shine. First theorem. Angle in a semicircle, 90. That don't mean this is 90. I take your time. MRQ. MRQ is this angle they want. This angle they want. So waiting for somebody to throw the answer out. A lot of people write 90. MRQ itself is not 90. RMQ is 90. So if this is 90, this has to be. So it's 70. Yes, it's 70 degrees. PMR. PMR. Ooh, that's a very interesting question there. It's kind of sneaky. Simple, eh? Quick. You can get PMR real quick, but it's a little sneaky how they do it. I must appreciate the cleverness of this question. Now, also, when you turn this open, you should be seeing that this is what? This is the double tangent rule, a very rare one, right? It only comes like once every 10 times. So what is PMR? Now, firstly, you should see what PMR is. PMR. And you can clearly see that this is a tangent and this is a chord. Angle between a tangent and a chord is equal to the angle in the opposite segment in the triangle, alternate segment. Yes, sir. $20. No, remember, I see it delayed there. Victory, I see it delayed. I see it delayed. Like there's a 10-second delay in case you don't know between when I talk. TikTok doesn't really have a delay, but YouTube has a delay. Can't believe TikTok boot me out because I couldn't just connect that puzzle, boy. TikTok were really wrong with you, boy. So this is 2020. And the last one. Hey, big up the past students who popping in. That was with me last year and year before, one thing in this sweat. PMN. PMN is free marks. What am I comedy free marks? So if this is 54, you them the subtract those. The 180 minus the 54 divided by 2, because you know that this is an isosceles. And when they bring this point with the two things outside, you know that's what they're gunning for one time. And everybody telling me that this will turn out to be 63 degrees. We cooking. So this is 63, and over here will also be 63. So PMN is 63 degrees. Moving forward. Last question for the night people. Again, getting chased off of the device right now. So we have EBF, but these are kind of like the most fun questions for me to do. I could stay up whole night and just do all out for you. BOA, AFB. Keep in mind, you have to write the reason that we stated it, and OAF. Last one for the night, OAF. Let's go. Yeah, boy, drifters. You have to take a little time out for that. A matter of fact, I should ban him. Take a time out. Take a time out. Because me know what possess you to write that in the people chat. Yeah, man. Blessings. Blessings to the past students who tapping in. EBF. EBF. That's this angle here. That's free marks. Because if this is 35 and this is the center and this is a right angle, then what does this mean? What are we missing there to make up that 90? Missing a easy 55, eh? EBF, 90 minus 35, 55. Bow constrictor, BOA. More free marks again. I'll see it as free marks as soon as I do this. Now, those of you all who not in the student tab and don't have the compilation, you could use my website, kewinspringer.com. Check the past papers and do as many as you can. Those of you all in the student tab, go get this. This is from the drive. Go get the circle theorem compilation and do as much as you can. So yeah, if this is 40, that means this is also 40. So this has to be 100. AFB is what? AFB. There's AFB. That's up here. That's free marks again. Right? I've seen people cooking up that one time. They got the 50 immediately. That one was pretty easy to see the arrowhead, right? Center, circumference, and OAF. My youngest son wants to show his swimming goggles. Say hello. OAF. This was an easy one, boy. OAF is this little sliver right here, which is pretty easy to get considering that we know all the other missing parts of that triangle. We know all the other missing parts of the triangle. So I can say 180 minus, and I can 50, 35, 40, 50, 35, 40, and another 40. Was there a faster, excuse me, was there a faster way to figure out that, boy? I'm not too sure, you know. I think I was forced to do that. Oh, I could have probably get this angle equal to this angle and just subtract here. So this angle, what is this? 55 minus 40, so 15 is 15 degrees. Yeah, so let me bring my hat. Should I bring it earlier? Yeah. So it's 15 degrees. All right. I hope this helped to improve your confidence. The very useful part was the mind map in the beginning. So those of you all who just popped in at the start of this, I did a mind map. That was extremely useful. How to memorize all the theorems. And I give some side quest tips that you need to pay attention to. we were able to complete what? 4 questions? 5, 1, 2, 3, 4, 5, 6, 7. 7 questions. 7 of these questions we did. That's 7 past paper questions. My aim, if I were you, would be to do like around 20. Like that's 10 years of past paper questions or more. So I just help you do 7. And I was teaching, and it only took an hour and 15 minutes. And plus we do a mind map. It's easy. Get the revision going. Love and blessings, people. I'm going to keep you back anymore. We'll be back at this again when we reach June 2013. Plenty more years to go, man. Love and blessings. Hold it on. Wait, where we reach? Yeah, June 2013, right? Later.